The construction of the International Space Station involved over 40 launches, years of orbital assembly, and billions of dollars in expenditure. The station has become a symbol of international cooperation and scientific achievement. However, the operational lifespan of the station, which is scheduled to be decommissioned from orbit around 2030, is also nearing its end. NASA has made one thing clear: no other nation will build the station. Instead, the agency plans to transition to a commercial model where private companies own and operate platforms in low Earth orbit, with government agencies only purchasing access rights. This shift has paved the way for new generation space station designs that seek to address the cost and complexity issues that define the ISS era. One of the most unusual proposals comes from Max Space, a Florida-based startup. The company is developing an expandable space station about 1/3 the size of the ISS that can be launched fully assembled on a single rocket and expand in orbit to create 350 cubic meters of pressurized volume. This concept is called Thunderbird. It consists of soft, layered materials instead of rigid metal modules and is designed to support a 4-person crew with a reconfigurable interior that can be adapted to different mission needs. This is not science fiction. Max Space has funding, NASA partnerships, and a prototype mission planned for 2027. If successful, Thunderbird could reshape what is possible in low Earth orbit and beyond. The idea of expandable space habitats is not entirely new. NASA has been testing this concept since 2016 with the Bigelow Expandable Activity Module (BEAM) attached to the ISS. BEAM demonstrated that soft-walled structures can withstand prolonged exposure to space radiation, thermal cycling, and micrometeoroid impacts without suffering catastrophic failure. However, BEAM was a small-scale experiment, essentially a storage cabinet attached to an existing rigid station. What Max Space proposes is fundamentally different in scale and purpose. Thunderbird is not an additional module. It is designed as a complete independent station, not an add-on, but the primary living and working environment. Unlike inflatable modules that achieve their shape through internal pressure, Thunderbird uses a structure composed of layered soft materials that the company calls a morphic internal structure, which folds during launch and unfolds and stiffens after entering orbit. Max Space argues that this approach provides more predictable structural performance and better scalability than fully inflatable designs. Thunderbird's most striking feature is that it can be launched on a single SpaceX Falcon 9 rocket. To understand why this is important, consider the ISS. The station's construction required over 40 launches spanning more than a decade. Modules were sent into space individually, docked together in orbit, and then outfitted with systems. Each launch added cost. Each assembly step increased risk. Once modules were connected, rearranging them became nearly impossible. Thunderbird eliminates all of this. The entire station, living quarters, docking ports, life support systems, and internal structure is launched compactly, unfolds in orbit, and becomes ready for use. No assembly is required. The volume efficiency is astonishing. Traditional rigid modules are limited by the size of the rocket's payload fairing. Only as much interior space as will fit inside that fairing can be launched. Expandable structures eliminate this limitation. Thunderbird's 350 cubic meters of pressurized volume is compressed into a form factor small enough to fit inside the Falcon 9 fairing, then expands to approximately 1/3 of the ISS's total volume. This means a significant increase in usable space per launch, which directly translates to lower costs. Max Space was founded about 4 years ago by CEO Salim Meenan, President Aaron Kemmer, and Chief Technology Officer Maxim de Jong. Kemmer brought to this company the experience he gained at Made in Space, a pioneer in microgravity manufacturing that was later acquired by Redwire. The team initially positioned Max Space as a supplier of expandable modules to other companies developing stations. This strategy changed in August 2025 when NASA revised its Commercial Low Earth Orbit Goals program and explicitly stated it would support multiple commercial stations rather than selecting a single successor to the ISS. This shift motivated Max Space to develop its own complete station rather than remain solely a component supplier. The company currently operates from a facility in Exploration Park near the Kennedy Space Center, employs approximately 50 people, and has raised over $10 million in pre-seed funding from strategic and institutional investors. It has also signed Space Act agreements with NASA. These agreements allow for technical collaboration without committing the agency to a full supply contract. One of Max Space's most significant hires was former NASA astronaut Nicole Stott, who flew on 2 space shuttle missions and spent time on the ISS. Stott joined the company as chief astronaut and played a key role in shaping Thunderbird's interior design. Her contributions reflect hard-learned lessons from the ISS. Throughout the station's operational life, new systems were constantly added to keep it functioning. Equipment racks, cables, cooling lines, storage cabinets. These additions gradually filled the available space, creating cluttered interiors that made it difficult to move around, work efficiently, or reconfigure the layout as mission needs changed. Thunderbird was designed to prevent this problem. Instead of fixing systems in fixed positions, the morphic interior allows astronauts to reposition equipment, create dedicated work areas, and adapt the environment, even during missions. Think of it as being able to move furniture around in a home, rather than living with a fixed floor plan forever. The station is designed to include over 60 reconfigurable cargo lockers, adjustable handles and footrests, large screens for Earth observation and communication, dedicated crew quarters, a common area for collaboration, and an observation gallery with domed windows. Human factors are crucial in space, especially during long-duration missions, and Thunderbird's layout reflects this reality. Safety is ensured through a multi-layered structure. The station's walls are not composed of a single rigid shell. They consist of multiple gas barriers designed to exceed the safety margins of traditional metallic pressurized vessels, micrometeoroid protection layers similar to Kevlar, and advanced fabrics that provide thermal insulation and structural support. Max Space has conducted extensive ground tests in environmental chambers to validate these materials under extreme conditions, but the real test will be in orbit. Therefore, the company is planning Mission Evolution, a small-scale prototype scheduled for launch in early 2027 on a SpaceX shared-use mission. The primary goal of this mission is to test the module's micrometeor and orbital debris protection system along with its environmental control and life support systems in a real space environment. If Mission Evolution is successful, the company aims to launch a full-scale Thunderbird Station in 2029. The implications of this approach extend far beyond replacing the ISS. If expandable stations can be validated at scale, they will change the economics of operating in low Earth orbit. Lower launch and assembly costs will enable more organizations, universities, smaller research institutions, emerging spacefaring nations, private companies, to conduct research and manufacturing in space without relying solely on large government programs. It will also enable the creation of a more distributed model for orbital infrastructure. Instead of a single large international platform like the ISS, the post-2030 environment could consist of multiple commercial stations, each optimized for different purposes: government research, pharmaceutical production, semiconductor manufacturing, materials science, even tourism. This diversity increases resilience. If one station experiences problems or goes offline, the others continue to operate. It also increases flexibility. Customers can choose the platform that best suits their needs, rather than adapting to a one-size-fits-all solution. Max Space sees applications beyond low Earth orbit. The company emphasized that Thunderbird's expandable architecture can be adapted for lunar surface habitats, Mars missions, and deep space transit vehicles. Mass and volume are valuable resources in exploration missions. A habitat that can be launched compactly and expanded at its destination offers significant logistical advantages. The company announced a partnership with Voyager Space to explore these possibilities. The partnership will focus on expandable structures for the Moon and Mars rather than just low Earth orbit. Whether this vision becomes reality depends on many factors: funding, regulatory frameworks, sustainable demand, and whether the technology performs as promised. However, the intent is clear. Max Space is not just building a structure to replace the ISS. It is positioning expandable living spaces as a fundamental technology for human presence beyond Earth. What remains uncertain is demand. Will there be enough customers to support multiple commercial stations? NASA has committed to purchasing services, but the agency's budget is limited. The real test will be whether commercial applications, manufacturing, pharmaceuticals, data processing, materials research can generate revenue independently of government contracts. Initial interest has focused on semiconductors and fiber optics, where the unique environment of microgravity offers potential advantages that justify the cost of operating in space. If this interest translates into sustainable commercial activity, the commercial station model succeeds. Otherwise, the post-ISS era becomes more uncertain. Thunderbird is a bet that expandable structures can solve the cost and complexity issues that make the ISS era unsustainable. A single launch, a reconfigurable interior, a human-centered design leveraging decades of experience in orbit. If Max Space can realize this vision, the way humans live and work in space by 2030 could be very different from today.